So the next category is the polarization diversity. So the next category is the polarization diversity. Here in this polarization diversity, different polarization are provided between transmitter and receiving antenna pair. So here in this method, different polarization are provided between transmitting and receiving antenna pair, and this diversity is primarily used for fixed radio link which vary slowly in time. So in this polarization diversity, the signal is transmitted by a pair of polarized antenna, and it is also received by another pair of polarized antenna. So in the receiver and transmitter, we are using a pair of polarized antenna in polarization diversity. And usually circular and linearly polarized antennas are placed, and this is about polarization diversity. So this diversity is primarily used for fixed radio link which vary slowly in time. And next is the frequency diversity. This method is implemented by transmitting information on one or more carrier frequency. So the principle behind this technique is that this frequency separated by more than one coherence bandwidth of the channel will be uncorrelated and will not experience the same fade. So here in frequency diversity, information is carried on the carrier. Like we send carrier signal, carrier frequency information is carried. So this method is implemented by transmitting information on more than one carrier frequency. So we are transmitting information on more than one carrier frequency. And the principle behind this technique is that the frequency separated by more than one coherence bandwidth of the channel will be uncorrelated and will not experience the same fade. So what do you mean by coherence bandwidth? This coherence bandwidth, it's a range of frequency over which the channel can be considered as flat. So it's a range of frequency over which the channel is assumed to be, or channel can be considered as flat channel. That is a channel which passes all spectral components with equal gain and linear phase. That is coherence bandwidth. So the principle behind that in this frequency diversity is that the frequency separated by more than one coherence bandwidth of the channel will be uncorrelated. So this coherence bandwidth will be uncorrelated, and the channel will not experience the same fading. So each channel will experience different fade. So in this, a new OFDM, that's orthogonal frequency division multiplexing technique, employ the frequency diversity technique. So this is about the frequency diversity. So in frequency diversity, signal is transmitted on one or more carrier frequency, and the principle behind this technique is that the frequency separated by more than one coherence bandwidth of the channel will be uncorrelated, and this channel will not experience the same fade. Fading will be different. And the new OFDM technique employ frequency diversity technique. Now last one is the time diversity. So in time diversity, in this method, information is repeatedly transmitted at a time spacing that exceeds the coherence time of the channel. So what do you mean by coherence time of the channel? We have discussed about the coherence bandwidth, and what do you mean by coherence bandwidth, coherence time TC? So coherence time, it's a statistical measure of time duration over which the channel impulse response is invariant. That means channel impulse response is invariant. Coherence bandwidth means it's a measure of time, or it's a measure of bandwidth over which the frequency is considered to be equal, or channel is considered to be flat. And coherence time means it's a statistical measure of the time duration over which the channel impulse response is invariant. Or in other words, the coherence time is the time duration over which two received signal have strong potential for amplitude correlation. So in this time diversity, In this method, information here, the information is repeatedly transmitted at a particular time spacing, and that time spacing exceeds the coherence time of the channel. So the multiple repetition of the signal will be received with independent fading condition. So we are transmitting a signal or information at a time spacing, and that time spacing, that this will be exceeding the coherence time of the channel, and so that the repetition of the signal which we are sending at a time spacing or at a particular time will be received with independent fade. So one signal will be experiencing a particular fading condition, and another time slot we are sending another signal. So that signal will be experiencing another independent fading condition. So this is time diversity. That is, in this method, information is repeatedly transmitted at a time spacing. That is, one will undergo reflection, one will undergo diffraction, one will undergo scattering. So same signal we are sent at the receiver, it is approaching at a different time interval, that is at a time spacing, and that time spacing exceeds the coherence time of the channel, so that multiple repetition of the signal will be received with the independent fading condition. One modern implementation of this time diversity involved the use of rake receiver for spread spectrum CDS. So the rake receiver means the main objective of this rake receiver is to collect all the time shifted signal, and it is after collecting all the time shifted signal, we get the correct signal, that is a transmitted signal. So this rake receiver is used for collection of all time shifted signal, that is by passing through the propagation channel, or by passing through different propagation channel, like while one will be by reflected path, one will be diffracted path, one will be scattered paths. So all this effect of the signal, or that means all this signal can be collected, and all the signal will be time shifted. So one will be at T1, one will be reaching at the receiver at T1, and another signal will be that can be scattered wave that can be reaching at the receiver T2, and another signal like diffracted wave may be reaching at the receiver at T3. So all these signals are time shifted version of a single transmitted signal. So this time shifted version is collected at the rake receiver. So this is the time diversity. So polarization diversity, first one was phase diversity. It was also known as antenna diversity. Second is polarization diversity. Here we are using different polarization are provided between transmitter and receiving antenna. Here we are using a polarized antenna, polarized pair of antenna in transmitting and receiving side, and this diversity is primarily used for fixed radio link which vary slowly in time. And frequency diversity, so here we are sending information on one or more carrier frequency, and the principle behind this technique is that the frequency separated by more than one coherent bandwidth of the channel will be uncorrelated, and this will not experience the same fade. And next is the new OFDM technique, employ frequency diversity. So OFDM technique provides frequency diversity, and here the time diversity, it is provided by the spread spectrum CDMA, that is core division multiple access. So in time diversity, in this method, information is repeatedly transmitted at the time spacing that exceeds the coherence time of the channel, so that multiple repetition of the same signal will be received with the independent fading condition. So this is about the diversity. Now we are going to the next topic, that is introduction to MIMO system. Like MIMO system. So this MIMO system or MIMO system, it's multiple input, multiple output communication system. So here this MIMO or MIMO system is a multiple input or multiple output communication system, and this refers to a collection of signaling processing technique to enhance the performance of wireless communication system using multiple antenna at the transmitter or receiver or both. So here this multiple input, multiple output, as the name suggests, here we have multiple input and multiple output. And this communication refers to a collection of signal processing technique. So this is a collection of signal processing technique to enhance the performance of wireless communication system. So by introducing this MIMO system or MIMO communication system, it enhances the performance of wireless communication system. Using this enhancement is by using multiple antenna at the transmitter or receiver or both. So here we are using multiple antenna at transmitter, receiver or both. and it is an antenna technology for wireless. So by introduction of antenna, this enhancement is achieved. So multiple input, multiple output communication refers to, it's a collection of signal processing techniques, and this technique is to enhance the performance of this wireless communication system using multiple antenna at the transmitter, receiver, or both. And it is an antenna technology for wireless system. In this, antennas at each end of the communication circuit are combined to minimize and optimize the data, minimize error and optimize data speed. So, and the antennas which are used in the both sides, that is in the transmitting side and in the receiving side. So, these antennas at each end of the communication system or communication circuit are combined. This antenna which is separated, multiple antennas are used. So, this multiple antenna are combined to minimize error and optimize the data speed. So, this MIMO is one of the several form of smart antenna technology other than MISO, that is multiple input, single output, and SIMO, that is single input and multiple output. So, compared to both this, MIMO is a smart antenna technology used in wireless system. So, in conventional wireless system or wireless communication system, a single antenna is used at the source and another single antenna is used at the destination. So, in conventional wireless system, single antenna was used at the transmitter side, that is the source side, and another single antenna was used at the destination, that is the receiver side. So, in digital communication systems such as wireless internet, it can cause reduction in data speed and increase in the number of errors. So, in the case of digital communication system such as wireless internet system, in this it can cause, that is by using single antenna at the receiver and single antenna at the transmitter, this can cause a reduction in data speed. So, and it can increase the number of error also. So, we go for this multiple input, multiple output system. Here we can see, in the case of conventional communication system, there will be a transmitter and there will be a receiver, and there will be only one antenna at the transmitting side and one antenna at the receiving side. And in the case of this MIMO system, we can see there are multiple antenna at the transmitting side and multiple antenna at the receiving side. So, if one of we can see that from antenna, transmitting antenna, one signal is going and this is received by these three antennas. It can be received by these three multiple antenna at the receiver side. So, if one of the path undergoes some fading, the other path can give the correct decision, or other path can transmit the correct signal to the receiver. So, the effect of fading can be reduced in this MIMO system or MIMO model. So, we can see here another multiple antenna is used in the transmitter which may transmit signal, and it is received by this three antenna, that is multiple input, multiple output. So, if one of the path undergo any fading or any other effects due to propagation path, the other path can carry the same signal. So, the receiver can get the transmitted signal from any one of the path. So, this is about multiple input, multiple output system. So, this is used to increase or enhance the performance of this wireless communication system by introducing multiple antenna and multiple input and multiple output. And here this MIMO system increases by introducing this MIMO system, it increases the coverage, and position estimation can be also be increased, and it have a good coherence also, and effect of fading can be reduced as the receiver can select one which with one propagation path with a good signal, and there will be no break of voice in calls also in this MIMO system. And this MIMO system is used in WiMAX, LTE, wireless local area network, in video and digital video and audio processing. And the disadvantages of this MIMO system is its complex array topology design. So the design is a little bit complex and it is a little bit expensive also, since we are using multiple input, multiple output antennas. So this is about the MIMO system. So introduction to MIMO system, once again we will refresh, that is multiple input, multiple output communication system, and this refers to a collection of signal processing technique to enhance the performance of the wireless communication system using multiple antenna at the transmitter. So we are using multiple antenna at the transmitter or multiple antenna at the receiver, or we can use the both, that is multiple antenna at the transmitter and multiple antenna at the receiver. So it is basically an antenna technology for wireless communication system. The antenna at each end of the communication circuit are combined to minimize the error and optimize data speed. So this antenna which we are using at the transmitter are combined to minimize the error and optimize the data speed. So by using this MIMO model, it increases the data speed also. So MIMO is one of the several forms of the smart antenna technology other than being MISO and SIMO. That is multiple input, single output, and single input, multiple output. So in conventional wireless communication system, a single antenna is used at the destination. So in conventional system, wireless communication system, we can see that in this figure, if you are using conventional antenna, there will be one transmitting antenna and there will be one receiving antenna. But in MIMO, there will be multiple transmitting antenna and multiple receiving antenna. So this is about the MIMO system, that is multiple input, multiple output system. So by this topic, the 5th module is completed. So we can discuss now the important questions in this module. So the first question can be what are the different handoff strategies, and second, what are the different ways to improve the coverage and capacity, and third, explain the different channel assignment strategies that we have studied: FCA, BCA, DCA, that is fixed channel assignment, then dynamic channel assignment, borrowing channel assignment, that are the channel assignment strategy. And fourth question is to write a note on trunking and GOS. And fifth question is to explain the frequency reuse concept. And sixth is explain interference and system capacity. Seventh question, explain free space propagation model. Eighth question, explain ground reflection model. Ninth question, explain knife edge diffraction model. That is wireless propagation model ഒരു question ആണ് knife edge diffraction model. പിന്നെ 10th question write a note on path loss prediction in hilly terrain. That is also comes under the wireless propagation model ആയിട്ടുള്ളതാണ്. Propagation മോഡലിന്റെ അണ്ടറിൽ വരുന്ന രണ്ട് important questions ആണ് knife edge diffraction മോഡലും പിന്നെ path loss prediction model in hilly terrain. വേറെ ഇതിന്റെ അകത്തുള്ള രണ്ട് propagation മോഡൽ ആയിരുന്നു ഗ്രൗണ്ട് വേവ് റിഫ്ലക്ഷൻ മോഡലും അല്ലെങ്കിൽ ടൂറേ മോഡലും അല്ലെങ്കിൽ ഫ്രീ സ്പേസ് പ്രൊപ്പഗേഷൻ പാത്തും. പിന്നെ 11 ക്വസ്റ്റ്യൻ എന്ന് പറഞ്ഞാൽ ഫേഡിംഗ് ആൻഡ് ഡൈവേഴ്സിറ്റി ടെക്നിക്. സോ ഫേഡിംഗിൽ നമ്മൾ സ്മോൾ സ്കെയിൽ ഫേഡിംഗ് പഠിച്ചു, സ്മോൾ സ്കെയിൽ ഫേഡിങ്ങും പിന്നെ അതിന്റെ ടൈപ്സും പഠിച്ചു, സ്മോൾ സ്കെയിൽ ഫേഡിങ്ങിന്റെ ടൈപ്സും. ആൻഡ് പിന്നെ ഡൈവേഴ്സിറ്റി ടെക്നിക്കിൽ നമ്മൾ ബേസിക്കലി 4 ഡൈവേഴ്സിറ്റി ടെക്നിക്കാവുള്ളൂ: സ്പേസ് ഡൈവേഴ്സിറ്റി, പോളറൈസേഷൻ ഡൈവേഴ്സിറ്റി, ഫ്രീക്വൻസി ഡൈവേഴ്സിറ്റി, പിന്നെ ഉള്ളതാണ് ടൈം ഡൈവേഴ്സിറ്റി. അതിൽ സ്പേസ് ഡൈവേഴ്സിറ്റിനെ ആന്റിന ഡൈവേഴ്സിറ്റി എന്നും പറയും. അതിൽ 4 കാറ്റഗറീസ് ഉണ്ട്. പിന്നെ ലാസ്റ്റ് ടോപ്പിക് ആണ് വാട്ട് ആർ മിമോ സിസ്റ്റം, എക്സ്പ്ലെയിൻ ഇൻ ഡീറ്റെയിൽ. സോ മിമോന്റെ ഒരു ബ്ലോക്ക് ഡയഗ്രം ഉണ്ട്, അത് നിങ്ങൾക്ക് ഞാൻ തരാം. അഥവാ മിമോ കുറച്ച് എക്സ്ട്രാ മാർക്സിന് ചോദിക്കുവാണെങ്കിൽ